Hello. Well, in just a couple of days' time we have a very interesting astronomical event coming up, and it's called the transit of Venus. So what is a transit, how often do they occur, and why are they historically significant? Well, a transit is where a smaller object, as viewed from Earth, passes in front of a larger object. The opposite, where a larger object passes in front of a smaller one, is called an occultation. So, the transit of Venus is where the planet Venus passes across the face of the Sun, as viewed from Earth. Now this event is actually very rare. In fact, it's only happened about 25 times since the Romans arrived in Britain, and only about 7 times since the invention of the telescope. There was one in 2004 and one in 2012. And if you've missed the 2012 one, the next one is on December the 10th and 11th, 2117. So, why 2 in the space of 8 years and then none for 105 years? Because of the motion of Venus and the Earth, it takes over 1.5 years for Venus to overtake the Earth again. Because Venus's orbit is tilted about 3.5 degrees compared to that of the Earth, this means a transit doesn't take place every time that Venus overtakes the Earth. In fact, a transit can only take place wherever Venus crosses the plane of the Earth's orbit. This happens in 2 positions. One is called the ascending node and the other called the descending node. Venus takes approximately 225 days to orbit the Sun, and the Earth obviously 365. This means that 8 orbits of Earth and 13 orbits of Venus take approximately the same amount of time. So after 8 years, Venus and Earth come back to the same configuration. So if there's a transit 1 year, then there could be one 8 years later. It isn't exactly 8 years, and so the precise alignment will be very slightly different at each 8-year period. In 2004, the transit moved across the lower half of the Sun. In 2012, it will move across the upper half. And in 2020, it will miss the Sun completely. So, because of the small difference every 8 years, the next time they'll become aligned again is more than a century later. So, why are transits of Venus historically significant? Well, before we observed a transit of Venus, we knew the relative scale of the solar system. So, for instance, we knew that Venus was approximately 72% of the way between the Sun and the Earth, but we didn't know how many miles that was. So, we're actually able to use the parallax effect, where we'll have observers at either end of the Earth, and we can use the minute change in the apparent position of Venus to work out how far it is away, and therefore how far we are from the Sun. The difference is actually quite small. It's about 1 arc minute, which is 1/60th of a degree. You can see the parallax effect for yourself by holding a finger up in front and alternatively closing your right and left eyes. The apparent position of your finger will appear to change against the background. So the idea is simple. If you can observe the precise time that Venus appears to enter and leave the disk of the Sun in different positions on the Earth, you can calculate how much of a shift in position you've had, and therefore how far away Venus is. In the 18th and 19th centuries, some people travelled many months, sometimes at great personal hardship, to observe the transits of Venus. Some were unsuccessful due to severe illness or clouds. For most, though, the attempt to measure the precise time when Venus exited or entered the disk of the Sun was followed by a curious phenomenon known as the black drop effect. This is where, instead of the precise moment when Venus touches the edge of the Sun being a sharp edge, Venus seemed to just merge into the edge of the Sun. So it made timing very, very difficult indeed. So unfortunately, some of the early measurements proved to be quite inaccurate, although they did provide some of the earliest estimates for the size of the solar system. So there you have it, the transit of Venus. Now remember, never look directly at the Sun without adequate protection, and sunglasses are not enough. One of the best things you can do is, if you do have a telescope, you can project it onto a sheet of paper and observe the sheet of paper. Alternatively, you could set up a simple pinhole camera. So, thanks for watching.